waste too much of my time. This is basically me. Let's get this over with. It's my role at the university. Oh, you want me to speak in this one? But I always move around. But I get the rock star kind of feeling here. In one of our courses on embedded programming, we switched and started to use Arduino. It was perfect. It was easy to get started with. The IDE lowered the threshold. When we introduced the Arduino or other hardware and show that to people who were new to programming, they've just learned Java, and all of a sudden we show them the command line, we show them scary tools. We noticed that when we introduced them to Arduino using the IDE, it was perfect, way easier. But doing that, we faced some problems. Problem is I usually read here, but I can't do it right now. So I'm going to show you my back. When we made a bigger project, not the examples you see in the Arduino, it was a couple of thousand lines long program, split into many smaller files, developed by several students at the same time. We had a problem. We tried using Git and cut paste and blah, blah, blah. It didn't work. We missed unit testing a lot. It's not as if you are recommended to use malloc and calloc in embedded programming. Still, it's good to do some unit testing every now and then to check the logic. And we noticed that it's pretty lame. You're developing this 4,000 line long program. You spent hours, weeks, and all of a sudden the LED doesn't blink anymore. So you have to debug it, sometimes using, well, code review. So we had a problem with that. And we also needed to automate the tests. So we realized that we had to write a sort of a faked environment. So basically we took the Arduino API, implemented every function, not every, but almost every function, the ones we use at the university, so we could create a program that could run by itself with no hardware. And then we added some small standard out, standard in interface to it, so we could set, for example, input pin 1 to 1 and see what happened in the code. But after a while, when we did that, we realized that we were almost done writing a simulator. So we finished one, we wrote one. And we got some complaints from students that didn't want to write unit tests in C. So we wrote a Python extension to it so they could write the unit tests in Python. And for the fun of it, I added a Java extension because I needed to refresh my almost totally forgotten Java skills. I want to show the classic Hello World example. It doesn't do good because there is no screen here, so I'm going to do it using a blinking list. So let's see what happens here. I'm afraid of this presentation program. So here is a blinking LED program. Also, there's some reading of one pin to another, but if we focus on these lines here, it basically puts the output on pin 13 to 1 and takes it down again to 0. So it should blink. How many have done these kind of things in front of a live audience and gotten away with it? Now it blinks, but let's try and upload this one. I'm going to show one of the most used features of the simulator. This is, by the way, the Arduino IDE, which is lovely. It really helps people to get over the first barrier. So I'm not here to bash this IDE in any way, but let's upload it and let's see when the LED blinks. Problem is that it doesn't blink. And this was something we, excuse me? Oh, damn it. Oh no, you weren't supposed to see this. Damn. What a disaster. I'm going home. Problem is my flight is on Monday. If I only can see my mouse again. Anyhow, Claude is, I'm going home. A lot of times, I'll never do that, which I just proved. A lot of times the students forgot to say what kind of pin 13 should be, or whatever pin you want to talk with. And if you don't set the output to 13, oh sorry, this pin 13 to an output pin, you cannot write to it. So this code is writing to the LED, but nothing happens. So now I'm going to show the simulator and how we develop code. And I'm using my favorite editor. Some of you may recognize it. It's Emacs. It's the only one I know. Okay, so this is basically the same code. It's writing to digital pin 13, first a 1 and then a 0. Basically, that's all that happens. So that's it. So I'm going to show you how we develop that. This is kind of hard. The only thing I do, I write a couple of, these are all the lines that I need to write as a makefile. And I here put the board. I want to program for Uno, but since the program didn't work, we are programming for something we used to call stub. It's not a stub anymore, but the name is still here. So what we are doing is, we are basically saying that don't produce code for the actual Arduino, but produce code to be run locally on this one. How am I doing on time? Good, but good depends on how much more I have to say. Perfect, thanks. So what the program does, or what Searduino does for me now is, given the C file that you saw in my Emacs buffer and the small make file, it produces a shared object. Basically dynamic library. And somewhere in the history here, I should have had, I have an installed version here. Man, I do type crappy. So I fire up the Java simulator. It's a big one today on this screen. I open up the newly, freshly compiled shared object. And what we can see here is, this time it's actually not a flaw in the simulator. You're seeing a lot of printouts here. It's warning. You're trying to write with the function digital write to pin 13. Let's stop it and look at the rest, which is an input pin. This was great value for the students. All of a sudden they could get feedback from the simulator saying that, oh, you're writing to pin 13, which is an input pin. So some of them asked me, what do we do now? And yeah, simple answer was, you need to initialize it as an output pin, and this is what I do here. So Woo. If I recompile it now as a shared library and open it up again, I can choose board here, but let's continue with, all of a sudden, we don't have any warnings. And we can see the pin 13 going berserk. So we can actually test that it is working. Nice, fine. And since we're, if we would have made a similar mistake as before, we would still see some warnings here. I just want to show you that we can also read the input pins. So in the program, if I click input, if input 10 goes high, digital output pin 11 should also go high. And in a rather slow fashion, it does. It's not due to the simulator, but the code that the simulator is running. So let's try and a quick with this code you develop with this program you develop C code that you run on the Arduino. You build it for Arduino, any board. You can run it as a standalone program, basically an ELF program. You run it. Or the best way, if you want to use the simulator, produce a shared object, upload it to the simulator, and run it. This is the basic. There's a couple of other simulators, but I'm running out of time, so I'm just going to show the Java sort of architecture here. This is the Arduino code built as a shared object. It's loaded by Searduino. We have a simulator API called csim. On top of that, we have a Java class that wraps all the simulator into a Java interface. And Searduino, we're not very good at names, is the Java simulator. That's it. We've done that. This, I'm happy that you can see. It would be great to have some people join us to develop this program further. We need more implementation of the Arduino API. I think it would be pretty cool to have an Eclipse plugin. Somehow, I don't know how. Make it possible to load Arduino's INO files. Basically, the Arduino files you get with the Arduino is C++ files, but they are called INO. It would be pretty cool if you could load them into this simulator directly. What we've done so far is we can take an INO file and translate, convert that into a C file, create some make files around it. So we're almost there, but we need some more help. We're running out of time. It's given the amount of time I have, given the 3 kids and everything else I do, we shouldn't have an active project, but it's listed on one of the sites, olo.net, that it's very active, so it is active, I think. We are building it every night using this tool, VMM, which is going to be, they are here, they're going to present something tomorrow. Why the name? C as in the programming language C. And one of my favorite books was called Deep Sea Secrets, so I thought the joke was so funny. So I wanted to have C. Well, you get the joke. I think, do we have any Swedes here? Okay, so I'm from Gothenburg, and Gothenburg are known and hated by the rest of Sweden for their crappy jokes, and we always want to play around with stupid names, and this is the result. So don't kill me. Sorry, I apologize. Questions? Nothing. Okay. Yeah.
Yes. Can you simulate analog conditions like analog voltages and, for instance, pin button bounce and things like that?
Uh, what was the pin button?
Sorry?
I couldn't. Can you say it again?
I mean, can you simulate analog
Yeah,
inputs? Yes.
and an analog, not analog out because it's PWM, but yeah.
Yeah. And things like button bounce, for instance, that would be useful to try.
I don't know. Perhaps it is possible. I don't know. The serial interface, for example, is implemented, and that is not answering your question. So let's talk afterwards. I just want to say a stupid mistake I did because I implemented the HID, the human interface thing, so you could. I have a Leonardo which was stolen the other day, and you can now simulate the mouse and keyboard stuff, but it turned out that when I did that using the simulator, it grabbed my mouse, so I couldn't stop the simulator anymore, and it kept running forever.